Hi, my name is Kaycee and Senior Vice President of Products and Global Field Operations. The good thing about presenting after David is that, number one, I always learn something new. Number two, whatever he talks about, I can now put on the roadmap. So that's fantastic, and you guys are my witnesses. I'm actually going to do the demo afterwards because I think we want to show you kind of some use cases, some benefits, some business benefits, and how customers are using primary data to provide more context. That and I need to switch laptops, so it's a lot easier for me to do it last. So we're actually going to go through this first. So let's first now we have a fundamental understanding of primary data, and David's done a great job outlining for us how easy it is to move data and the platform that we have and the objective-based data management, the controls that we have to determine what to where to move. We actually want to show you the different business challenges that we can solve with primary data. So these are challenges that a lot of customers have. These are use cases that a lot of you guys may actually encounter already. So things like data migration. How do you simplify data migration from a year to maybe days? How do you guarantee that data can seamlessly flow from your legacy storage to your new platform? Things like scale-out NAS or any type of scale-out infrastructure, be it building something new or leveraging the existing NAS solutions that you have. And data lifecycle management, right? Taking things like auto-tiering but going to the next level. Instead of just moving data up and down within an array, think about now doing it across arrays and across to different storage platforms and different storage vendors to get different levels of cost and performance and manageability. And we'll also talk about things in terms of how we can actually improve the overall vVol experience and capability as well. Let's talk about data migration for a second. As David mentioned, it's not uncommon for us to go, when we talk to customers, it's almost one of the first reactions they have when they figure out that we can help move data seamlessly, is I have a data migration problem. And the problem usually, a big bulk of it is usually around planning. Figuring out which applications need to be taken down and when, what's the level of disruption, and so forth. And so it takes a lot of coordination across all the app admins, database admins, storage admins, etc. It's not uncommon to have several months of planning before you actually even start doing the work. Then when you start doing the work, there's extra gear involved. There's Swingbox, there's professional services. It becomes pretty complex and pretty expensive. With primary data, this becomes, we like to say, the last data migration you ever need to do, in the sense that once Datasphere is added, and as David talked about, the ability to now create a global data space across any and all types of storage you have, data migration now is simply a simple, relatively easy task in terms of just moving data from one directory to another. Except in this case, that directory could reside on a completely different storage. And so this allows customers to start thinking about things that they couldn't do before. Whereas you might keep a storage array on maintenance for a long time because you're dreading the painful process of data migration. In fact, we're working with a global bank that is doing that. They have decided they no longer want to buy new storage from vendor X. However, the cost and the pain of migrating is so expensive that they'd rather just pay the maintenance and so forth. But that becomes very expensive over time. What if you could seamlessly move to any vendor, any platform, any form factor, anytime you want? Then this becomes pretty interesting. One of the CTOs of a large global telecom company, the way he explained it to us is, now the notion of actually leasing storage makes sense, because I don't necessarily need to keep everything for 3 years. If something better comes out, something cheaper comes out, and there is no friction to move and migrate data, we can simply do that and take advantage of better economics or better performance or easier manageability with a new form factor. And if you think about how to quantify the business benefits, obviously there's savings in terms of labor, in terms of the planning, level of effort, level of man hours required for planning and actually executing the migration. But one thing people don't take into account is how quickly you can get off maintenance on the old gear. Right? What if you didn't have to pay that dreaded year 4 maintenance? I'm not going to say every storage vendor does this, but I used to work for a large storage vendor, and it is common that when year 4 comes up, there usually is an increase to your maintenance bill. And what if you could avoid that by being able to go on to a new platform seamlessly, very easily? This is actually a real life example of a case we're working with the customer, and this is the amount of dollars we can save them from just a data migration effort.
Just a quick question on that. I would have said, say, 5 or 10 years ago that would have been the case, because a lot of the time you had dedicated physical servers. You may have used volume managers to map them up to the application, and migration was a real pain. But if people are heavily virtualized nowadays and they've got things like storage vMotion, is that really as much of an issue for people as it used to be to move their applications, especially virtualized ones, across and around compared to what they would have done 10 years ago?
So yes, definitely storage, vMotion, CRS has made things a lot easier, especially in a virtual environment. But there's still things like planning in terms of which applications need to go down, especially if you're changing different storage systems, how long and how disruptive that might be, what the performance impact might be when you're moving the data, even through storage vMotion.
Okay, I was involved in something a couple of years ago, and the majority of the issue was the non-virtualized stuff, which is the same thing you said.
Correct.
But for the virtualized stuff, the guys did it in a couple of weeks, and they just did it off out of hours. Not necessarily at weekends, just out of hours, out of the busy periods, and let it all sit and run in the background. And that side of it went really easily. So we didn't have any of these issues to deal with.
It is easier, but I think as for example, you start saying, I want to go from SAN to hyper-converged, right? Or while I'm doing this, I also want to incorporate object storage, for example. These dynamics kind of usually come in when you're doing a data migration. You're thinking, I'm going to go through this. I might as well, if I have to deal with this pain, I might as well add in all the other things I would have added anyways. So it's usually when the incorporation of that complicates the length of the project. But you're also right, it is a lot worse for physical environments.
But you can also say that the answer is, do you really want to be locked into a specific virtualization provider now?
Well, I would be if I took your solution. I'd be locked into your solution, wouldn't I? So,
on the data
you can say that on all of those, but I entirely agree with you. I think it's definitely the case with physical servers. I think there are a lot of use cases where it's definitely been simplified and it's not as tough as it could be. But I agree.
But even on in a VMware environment, we're doing storage vMotion, right? The ability to schedule this, the ability to say, I want to move files of this size first. I want to move files of this.
Yeah, that's true.
So there's the level of prioritization and automation. Like you don't want to treat everything the same, right? You kind of want to focus on your most important data first, for example.
No, I'd agree with that.
So there's things that we can do there that definitely complement and make that process a lot easier. So then let's talk, the next use case that a lot of customers, when they come to talk to primary data, that are interested in is scale out. And David mentioned earlier that scale out for us comes very naturally. And not only does it come naturally, but we also allow you to deploy scale out with a couple different flexible deployment options. Number one is you can definitely do a hyper-converged option. And here you can do a couple things. If you're using Nutanix, you're using vSAN, simply add those to the global data space and boom, that becomes just yet another storage tier. The other is using DSX, as David mentioned, where we can actually make the local disks shareable across all the physical servers. So now you can start incorporating things like non-volatile memory, NVMe, solid state disks, et cetera, to have now different classes and different versions of scale out with super high performance, and using the objectives that you can create in primary data to be able to make sure that you have great locality of data, so that you're not trying to access data on one node while it's residing in 5 different places across other nodes. The other example is now taking a white box approach, right? So you can take an x86 server with internal SDS, with internal HDDs or NVMe or SSDs, and treat that like an Isilon, right? Treat that like a solid fire, and now being able to have much higher performance as well as much lower cost and not being locked into any particular vendor. And then the third option, which is actually...
How would your pricing work? What would the price be compared to doing it the other way?
Yeah. So number one, we're not in the storage business, so we don't sell storage. So This configuration you see here will recommend a hardware partner that we've certified on. So for example, Dell or Huawei, to say, hey, this is the model that we've tested and certified on. These are your bill of materials. You can either work with your vendor or we can work with them to get you the hardware. Because we don't charge for that, all you have to pay is the DSX licensing plus the Datasphere licensing. So from the cost of storage perspective, it is much, much lower. In some cases, we've seen several orders of magnitude lower than the existing scale-out solutions out there. The third deployment is also very popular, especially around with customers with NAS filers. So this is where customers say, for example, they might have a bunch of 7-mode filers, and if they wanted to simplify manageability by creating a cluster out of them, today you might have to think about going to, say, NetApp cluster mode. And that could be a bit of a complex process and maybe even expensive to do. And you may not need all the advanced functionality of NetApp C mode. You might say, I'm happy with 7-mode, but I just want to simplify the management and scale out. Adding primary data allows you to do just that. And then to be more interesting, being able to now create a single scale-out cluster with different vendors. So I could put a EMC-VNX, a NetApp, Isilon, a Dell Compellent all together and make it look and scale out like it's one entity. So these are the different flexible deployment options that we have from a scale-out perspective.
Can I ask you sorry to interrupt, one question?
Sure.
You talked about banks and helping people and those sort of things and some of the different filers and so on. In my experience, especially in large environments, a lot of the problems that we ended up having was because of people's laziness, especially with things like NetApp filers where you could put links between filers in any direction, and people just got lazy and didn't stick to standards.
Yeah.
What's to stop people ending up with a situation with your product where they effectively do that as well? I mean, I saw that, for instance, I saw that a lot in SVC where people would just carve up chunks of the physical storage and remap it to LUNs, and you were unpicking an absolute mess.
Yes.
What's to stop people having that similar scenario with your platform? How would you sort of make sure that they don't end up with something where this, it's almost impossible to work out the mess of the spaghetti? So
basically, just because you can do something doesn't mean you should do it.
The important thing is namespaces are separate from the physical containers. In the past, they were one-to-one, right? So even if they make a spaghetti situation where you have this namespace with that namespace mounted here, or with a symlink over to that one because it's assuming it's mounted this way, that's all preserved in your logical namespace. And now you don't have to change that to be able to decommission and move and change the physical storage underneath. So which goes to the fact that you had a bunch of these namespaces in the first place because you had a whole bunch of separate storage things. And so what do? You graft all these namespaces together and put links in them. That's why when we talk to customers like in the media and entertainment space, they say, I have this nasty auto-mounter foo and all of this stuff for shifting it around, but invariably somebody's not using the nice symlink that we set up, and they're going underneath and using a direct mount point, and then it all blows up when we try to move it around.
Yep.
So here we avoid the problem because you don't have to separate it into a gazillion different namespaces, one for each storage container. You don't have to graft them all together, so you don't grow a bunch of spaghetti links. Your namespace can be sane based on the content, the data in it, not based on how it's fractured across your storage.
Yeah, and to add to that, people got into problems because when you start mixing storage arrays with different capabilities, different performance levels, that becomes quite a mess. This is where the power of the objective-based data management David talked about. So now we have full understanding of the capabilities of the underlying storage, and we have full understanding of the objectives of the applications. And by appropriately matching them, we're going to avoid putting something that needs to be fast on something that's slow, for example. So let's talk about data lifecycle management, or what we call DLM, right, for short. This is the ability to, by policy, by rules, by objectives, basically controls that you define, to be able to say, I can now move data to the right place at the right time, regardless of vendor, regardless of protocol, and regardless of type. And so what this allows the data to do is, when it's dynamic, when it needs high performance, it could, for example, leave NAS and go to server-side flash. However, when the workloads are not as intense, it could leave server-side flash and maybe go to NAS again or go to a SAN. And when you have a policy that says, if this hasn't been accessed in 9 months, please preserve my storage, my on-site storage, by putting this into off-site object storage. So this allows this dynamic movement of data and treats different storage arrays, different storage types, almost as if they're tiers within one single storage system. This is different than, say, auto-tiering, where you're just moving data up and down inside an array. And this is different from the old days of information lifecycle management, where it's just a one-way street. You just keep going from fast all the way down to slow, and it's all designated to one vendor. Because today we live in a world where things are dynamic. What isn't active today could be active 3 months later. What is active today may not be active 2 days later. And this is so hard for organizations to respond, and it's what leads to things like over-provisioning or over-subscription of resources that Lance talked about earlier. And this is a bigger problem than you think, because not only does it create a lot of excess storage in what you currently have today, but it also leads to over-provisioning when you're purchasing and planning new storage. Many times we talk to customers, and this is the problem they have. We're about to buy some flash storage, we talk to our business units, we add up the pool of applications that they need, and it's 100 terabytes, so I need to go buy 100 terabytes of flash storage. Nobody asks, of that 100 terabytes, how much of it needs to be on flash all the time? And nobody asks because today there is no good way to move it in and out of flash whenever you need to and when you don't need to. So with primary data, what you're allowed to do is you now can play an intelligent time-sharing game where you can actually still successfully meet the service level objectives or agreements for your customers without having to over-camp or over-subscribe to resources by having stale data on expensive resources. And here's an example of that with one of the customers we're working with in terms of how much storage cost they can actually save if they had automated data lifecycle management with primary data. And what we found in this case is they have obviously some expensive high-end storage arrays where they want to put their performant data in. However, a lot of that data is camped, meaning application group said, hey, I need this, even though it may not be used, or even though they don't even have data there yet. It's sort of camping out because they're afraid when they need the performance, they're not going to get it. And there's no fast way for IT to respond. And then they have different tiers all the way down to scale out NAS. And what we can show them is a couple things. Is one, we could intelligently archive data to object storage while preserving it in the same namespace. So to the users, the data is still there and still accessible, but it's for the cold data, it's now consuming much less expensive storage. Two, based on when you need the storage, we can then move it up or down outside of the array. And so we can move it to compellent, or we can move it to, say, Isilon when it doesn't need to be so high performant, or we can move it back up to VNX. Or we can even introduce a super high performance scale out tier using scale out DAS with NVMe. So these are the kind of things that are now possible that with primary data, instead of spending 5.7 million, it could be a much, much lower total cost of ownership.
So if I want to include an array in the setup, should it be empty, or can it exist with
Yes.
data?
You can have a section,
Yeah.
you can have LUNs on it that are still used outside of primary data.
Okay, but if I want to use a storage box, I have to have like empty space that I can use. It's
Yeah, when you add in the, when you add it into primary data, you can select which LUNs for primary data to own and use versus, leaving alone those LUNs on that
but
side.
they should be empty, right?
Yeah, if you want to preserve the data.
Exactly.
Yeah, in the case of NAS though, when you point it at it, if it finds data there, it can go ahead and assimilate that into primary data. Because unlike block storage, it's a file system and it has identities to the data that's in it.
So one of the issues I see is that in order for you to understand the storage attributes and that sort of stuff, you almost have to be very knowledgeable about VMAX, VNX, Isilon, whatever the device is. What devices do you support? from that perspective. You know, I understand, I don't know, it doesn't matter, but,
Oh, I was going to ask if I had my mic on. So from a performance perspective, because we've instrumented the clients with telemetry, we can learn the performance of the storage.
IOPS, bandwidth, latency, I understand that.
And specifically from the point of view of the individual clients, so you can determine proximity when it comes to placing it. So it's much more powerful. When it comes to the other capabilities, those are, well, somewhat subjective. What's the availability? What's the durability? What's the, well, if you have security, does it do encryption at rest, in flight? You know, these kind of questions can be answered. Whether it supports the data services that we might tie into, we can know a lot of that in advance, and even know that generally speaking, a NetApp filer of this mode is considered to be 4 nines or 5 nines, and right. So most of the stuff is inferred to where the user's not really having to say that much about it. You go and refine it and say, well, I know I'm running this with this certain RAID level and whatever, so I'm going to say it's a little bit more reliable or a little bit less reliable, but that's in the noise at that point.
Yeah, so in short, right, I mean, one thing is, like David said, we have telemetry so we can detect, you know, things like performance attributes.
I understand the telemetry, no
right.
question about it.
So
It's the functionality,
the other stuff like
availability,
dedupe, compression, 5 nines, 10,
yeah,
whatever.
dedupe.
Those things we actually have the ability in our product, which we'll show you in the demo, where customers can actually input that. And so that in that aspect, we do rely on the customers to make those inputs. Or over time, as we learn about the arrays, we can pre-populate. You know, for example, this is a VMAX. We know it has fast and fast VP turned on. We know it has, you know, a caching layer turned on, for example.
But
so
that's
over
all
time,
performance
we'll
then.
do that, right?
Some of that may or may not be
Relevant?
licensed, right? I mean,
Correct.
it may be present, but not turn on, enableable and stuff like that.
Which is why you'll see later in the UI, we make it enterable and editable by the customer. And so if you have entered it, then we'll take that data point into consideration for the objectives for deciding placement and movement. If it's blank, then it doesn't get factored into the decision making.
Do you suggest your end user to reconfigure the arrays in a standard way, like all the LANs similar or whatever?
It can be beneficial to present the array as more pure plays and let us do the placement. So while they might have multiple types of media and be able to do auto tiering and stuff inside, it's almost better that they export something where they've spec'd the array to export all of its high performance stuff through here, all its medium performance stuff through here. That way you don't have, you know, them juggling things underneath when we can do a better job placing it based on having visibility at the client. So to that extent,
a huge migration of the.
so, yeah, that would be a very general rule of thumb. Is the simpler and straightforward and single purposed you can make the arrays, the better off, because then we can manage, equalize the demands ourselves on the outside better. But if not, it's fine. It's just that it leads to more variability in the performance level if it's also doing tiering internally and that sort of thing.
Okay.
Can you just go back to the previous slide on your numbers? What were you implying with this when you said this? When you said saving, are you saying somebody restructured it or just didn't buy in the same purchasing process?
Great. Let me clarify that. So the way to interpret this was if they were going to buy this today, and without primary data, this is what it would have cost. With primary data, this is now the new cost. That's one way to interpret it. The other way is, for example, as we free up all the capacity on the VMAX by moving it to something more appropriate, this now frees up that capacity. They've already spent the money.
Exactly. That was
they've already
my
spent
point.
it, right? You can't
Cost avoid, not cost
it's cost
savings.
avoidance at this point. So any new projects that are coming up, you now have a fully blank VMAX that you can now deploy on without having to wait to buy new storage to be added in.
So in the case of a migration to a new storage array, would you just put the new array behind your software and then migrate live?
Yes. So once the storage is added to our global data space, now it's visible and now it becomes another target that primary data can move data to. Any questions? Now let's talk about virtualization. I've been following the tweets and a lot of interesting tweets around vVols. I think a lot of people in the room agree vVols is a good thing. It really should be adopted more. And why isn't? Well, There's a couple reasons why it isn't, and we believe primary data can actually help accelerate the adoption of vVols. One reason is manageability. Today, if you want to deploy vVols, each storage array is its own vVol data store. So there is complexity in management. On top of that, you have to buy a storage array that has been successfully certified with the latest VASA provider. And so you're kind of dependent upon the storage array to do the certification to make their storage vVol certified and vVol capable. A couple problems with that. One is storage arrays want to differentiate themselves from each other by saying, I can do this, I can do that. vVols is great for customers, but it kind of normalizes all storage to some extent because it makes all storage VM aware, which is fantastic for us and for customers. But if you're a storage vendor where your unique IP is I am VM aware, you're not going to go out of your way to certify every single product you have to make sure it's vVol certified. So the challenge that presents for customers is if you want to deploy vVols, you may have to wait a long time, and then you have to do a disruptive upgrade, a rip and replace of your existing storage. So with primary data, as Lance and David talked about earlier, one of the benefits we have is, so we now become the universal VASA provider. So that means the storage array doesn't have to be a VASA provider. It doesn't have to be vVol certified. It doesn't have to be vVol capable. So you can now use your existing storage and get vVol capability and vVol awareness, or have the freedom and flexibility to buy any storage array and make sure that it's vVol capable and vVol aware.
So do you only do vVol, or?
No, we also support 5.5 as well. It's for 6.0. We use vVol in the VASA 2.0 as our API and talking to VMware, but we can also support a non-vVol environment.
Okay.
And then once the storage is in and once primary data is the sole VASA provider, now going forward, regardless of how many storage systems you have, from a manageability perspective, your vCenter admin is only managing one vVol data store. So that makes the management of the storage much, much easier, much, much simpler.
So the implication of your drawing, the way you've drawn it, implies that on that side of the picture, you couldn't easily move vVols between data stores. On this side of the picture, you could easily move vVols between data stores.
Yes.
But not actually rely on the hypervisor to do that migration for you.
That's correct. There's that, and with...
Is that, so you can do that? So you
Yes, you can.
Yes.
And that way you keep the same policies, because
Right.
the policies are specific to the storage vendor. So now you're kind of,
Right. And in this scenario, what happens is each of these have to tell VMware, no, I'm the master, right? And so when you have a VM, you have to actually manually decide where you want to place it if you don't necessarily want it to all go directly to that particular storage array. So that becomes a bit of a management nightmare if you're setting policies for SLAs and purposes. So this is one reason why we believe vVol adoption has been a little bit slower than it should be when we talk to customers. And so this is what we're doing to simplify that.
Okay.
The other aspect we're doing to simplify vVol adoption is integrating with storage policy management from VMware. So the integration is done within vCenter. So from a vCenter admin perspective, you can still use storage-based policy management inside. It's just the logic now on the back end is driven by primary data. So for example, when someone sets up storage and different classes of storage in vCenter using storage-based policy management, this is probably something very common. This is my gold, silver, bronze. This is my fast, medium, slow. And it's a bit of an arbitrary designation, right? There's no logic that says you cannot make the SSD tier the slow tier, right? You cannot make the SATA tier the fast tier. It's completely up to what the admin wants to do. Add in primary data, and now we can have some logic. We can say, well, this is fast because I need 25,000 IOPS. This is slow because I only need 2,000 IOPS. Or this is bronze because it only has 2 nines of availability. So it becomes a lot more logical why you have these tiers, because these tiers align to the SLOs that you have for your VMs and your applications. And you would call that in our world the basic objectives. Take that one step further with primary data with smart objectives, which David has talked about and we'll show you later in the product. We can get even more granular. Now we can say, instead of treating everything within that VM exactly the same way, I might say, well, certain VMDKs might need to be treated differently than, say, vSwap files, than, say, VMX files. So now it allows me to actually define by specific file extensions, what level of performance I want that data to be on, what level of availability, of protection, etc., or different array that I want it to be on. And I can now dynamically move them interchangeably across the different vendors and for different reasons, right? Driven by us, right? So not relying on storage vMotion to do it. This is now triggered all and controlled by primary data. So this works today. This complements storage-based policy management. We talked to a lot of customers, and this seems to be the missing link in their environment to make storage-based policy management something that they can deploy. Because now they can't get in trouble because they can define the logic. Primary data is the backend logic. The vCenter admin still uses, the interface that they're familiar with, and they get the advantage of not having to over-provision, managing only a single vVolt data store, and have the right data placed at the right time at the right location. We're working just from a business perspective. We're working with several customers now who have deployed and used primary data in their lab, still testing. And across this is different number of verticals. A lot of Fortune 2000 customers, a lot of scale-out customers, media and entertainment, HPC, government environments. So it's very common for us to be in a multi-petabyte environment, for example, large several vCenter cluster environments. So all these environments, allow primary data to be demonstrated for scale, for performance, as well as for the functionality of being able to set objectives and being able to freely move data to the different locations and different storage arrays based upon the business policies.
Do you have any experience with industries such as healthcare, for example, which have, let's say, data classification imperatives, which kind of mandate where you can put your data, and does your product exist?
The data sovereignty?
Yes. So that's the data sovereignty that David's talking about, where we can actually, through a rule that you set in primary data, you can say, I don't care if you get better performance by moving it here. Because of my sovereignty rules, I cannot have this data leave this particular location.
And I guess this is tied as well with the feature which is coming soon about, let's say, the data center placement.
Correct. Once we get federation, it ties into being able to move to different data centers or not leave that particular data center, for example. Okay. If there are no other questions, we will go to the demo.
I do have one other question.
Yes, sir.
It's a futures thing, I guess. What about the support of containers? Obviously, within the container environment, that would be a share on a server. Potentially, you've got the ability to be the name provider, or at least the mapping that says this container maps down to something, storage-wise, and be able to shift that around the infrastructure so that if a container moves between one server/platform and another, you can repoint the container endpoint effectively to somewhere else, and you can know what the security is.
It makes it really simple for containers. It makes it very, very simple, because it's just a single global namespace, and underneath we can affinitize the data, or they can write the policies to manually place the data alongside if they want.
Yeah.
I think you've been looking at my roadmap slides, haven't you? No.
Somebody had to mention the container.
It's totally valid, right? And I think one of the things that make container usable is, to be totally mobile and agile, which is why you go to containers, you also want to move data, right? And today, moving data in containers, it's not live, right? You have to close it down.
Absolutely.
So we enable the live mobility. The global namespace now I can do it in the cloud, on-prem, on DAS.
But more importantly, I think it's the endpoint. It's that fact that whatever it's mapped to, if the container goes, you need to be able to say that container was an object endpoint that had certain
associated,
and everything else, and that's what you want to have the metadata to be able to map when you move it and understand how to control that. And you've got that in your metadata engine effectively.
That's correct. Correct. Yes. Yes, sir.
Yeah. So this is probably a bad question, but I can't refrain to. So. Many before you tried storage virtualization of some sort, Hitachi, IBM, and the other. different times, different technology. Okay, I understand everything, and I really like what you do. But actually, not from a technical point of view, they all failed because they went out with this great technology and was a ring to rule them all, whatever.
Yeah.
And you have that ring today, but actually, you have all the vendors that are rowing against you. You know.
I knew he couldn't resist this.
I can't resist this one. I helped create the problem that makes this the solution. With the advent of very high performance flash and server-side flash, and with the advent of cloud and object storage, there's simply too much to gain by getting out of the single silo. Before, you didn't have as much to gain by getting untrapped from the silo. But now, when we look at how much improved performance and how much improved cheap capacity you can get, it's several orders of magnitude cheaper performance, flash attached, or server attached flash, and it's several orders of magnitude cheaper capacity to have just a cheap, deep object store.
Yeah, from one point of view, it's dispersion of resources. So
That's right, and the scale of it has gone to where, you know, you can't fit enough in one silo. You can't fit enough cheap performance, you can't fit enough cheap capacity density. Isn't it interesting to note that on the ultra capacity side and the ultra performance side, we've gone to scale out architectures. Object stores are big scale out commodity servers with disk, and server-side flash are your commodity servers with flash, right? So we've gone to scale out models on either side of the performance capacity spectrum. And this is basically ripping apart the whole notion of silo-based managing of data. You can't do it. So therefore, the benefit of virtualizing the data is very powerful. The other main thing I'd say is that most of them went after virtualizing the storage, which is to say make a bigger storage container from smaller containers, put aggregating containers. And that's missing the point. It's making a bigger silo from a smaller silo, but it's still stuck in a silo, specific to that type, specific to that vendor, etc. And that, it just makes your problem worse. I love the fact EMC used to point fingers at Fusion.io. You'd go to customers and say, yeah, that Fusion.io stuff's really good, but you end up with an island of data inside of each of your servers. And we'd have the same customers report back to us how they put EMC in their place by saying, yeah, but you're an island of data in my data center, just as isolated, and even worse because it's huge. It's too big to manage and not fast enough to move it around. At least with Fusion.io, I can move those things around quickly. They're high performance and small enough. No matter how you slice it and dice it, silos are problematic, and it's only gotten worse as we look at the proliferation of storage vendors. I mean, look at how many different vendors there are in an organization. So it's really those two things. The performance capacity spectrum is stretched several orders of magnitude. The number of vendors and the number of point solutions for different symptoms of data being siloed has gotten horrendous. So it's the same reasons why VMware came at a timely point in history. VMware came when we started getting multi-cores and a lot of underutilization. This is the same thing that's happening in the storage world.